चलो ठीक है, तो पहला जो टेस्ट था सेशन 1 शिफ्ट 1, राइट? लेट अस डिस्कस दैट पेपर. ओके, let us see how to solve this paper in under 40 minutes, right? Okay, right. So the first question is position of an ant S, right, in meters moving in YZ plane is given by S equals to 2t square j cap plus 5k cap. Where t is in seconds, the magnitude and the direction of the velocity of the ant at t equals to 1 second will be. So हमें, like, we have to find the magnitude and the direction of velocity. So we have given S. So if I differentiate S with respect to time, we will get velocity. So velocity will be, sorry, that is not writing. Yeah. Okay. So we have given S is 2t square j cap plus 5k cap. So if I differentiate this, ds by dt is velocity. So it will become 4t j cap plus 0, right? Because 5 is constant. Now this is the velocity, and velocity at t equals to 1 second will be 4 j cap, right? 4 j cap. So it is in the y direction and the magnitude is 4. So option 4 is the answer. Got it? Straightforward question.
Yes.
Next. Given below are two statements. Statement 1, viscosity of gases is greater than that of the liquid. It is incorrect, right? Viscosity of liquid is more than the gas. Is it clear? Right. So
Yes.
statement 1 is incorrect. And statement 2, surface tension of the liquid decreases due to the presence of insoluble impurity. Yes, this is correct. Why it is correct? So when we have, let us, there is a beaker, and in this beaker, let us say there is water, right? And we have added some insoluble impurity, let us say oil, right? So we have oil, we've added some oil. Now, due to this oil, what would happen? If I consider a molecule on the surface, now there will be a force of attraction between the molecule of the this oil molecule and this water molecule. Can we say that? Earlier there was you can say water molecule and water molecule attraction. Now we have water molecule and oil molecule attraction, right? And cohesive forces in general is more stronger in comparison to adhesive forces. What is adhesive? Adhesive is the force between the molecules of different substances. Cohesive force is the force of attraction between the molecule of same substances. Is it clear? So here you can say the net downward force decreases, right? So when that force decreases, the surface tension decreases. Is it clear? So when you add insoluble impurities, surface tension decreases. So this is correct. So statement 1 is incorrect, statement 2 is correct, right? Clear?
Yes.
Okay, now let us see the next question. If the refractive index of the material of a prism is cot A by 2, where A is the angle of prism, then the angle of minimum deviation. So we have given refractive index, right? So what is the formula of refractive index? It is mu equals to sine del minimum plus A by 2 divided by sine A by 2. Is it clear? And mu is given as cot A by 2, which can be written as cos A by 2 divided by sine A by 2. Now this sine A by 2 will get cancelled out. So we can write sine del minimum plus A by 2 will be equals to cos A by 2 can be written as sine of it can pi by 2 minus A by 2. Clear? So from here we can say del minimum will be equals to pi minus 2a. Got it? Straightforward question. Option 1. Next, a proton moving with a constant velocity passes through a region of space without any change in its velocity. So velocity is not changing, right? If velocity is not changing, the direction as well as the magnitude is not changing, right? If electric field and magnetic field represents the electric field and magnetic field, okay, right? A and B are the electric field and the magnetic field. Then the region of the space may have, so we have given 4 options. Option A, E is 0 and B is 0. If both electric field and magnetic field is 0, there will be no force, right? If there is no force, there will be no change in the velocity. So A is correct, right? That is possible because the particle is moving with the constant velocity. Electric
Yes.
field is 0, magnetic field is non-zero. Is it possible? Suppose if there is a particle which is moving in the right direction. If magnetic field is in the right direction, then there will be no magnetic force. Clear? When velocity and magnetic field are in the same direction, the magnetic force will be zero. Again, the velocity will not change. So this is possible, right? If B and V are parallel to each other. Now let us see the third case. Electric field is non-zero and magnetic field is zero. So when we have non-zero electric field, there will be an electric force. Is it clear? There will be an electric force. If there is force, there will be a change in momentum or there will be change in velocity, right? So option C is not possible. Now let us see D. Electric field is non-zero, magnetic field is non-zero. Suppose we have electric field such that electric field and magnetic field in such an arrangement where the magnetic force and the electric force are balancing each other. Let us see an example. So there is a positively charged particle, let us say Q, and it is going in this direction with the velocity V. And let us say there is a electric field in the upward direction, right? So due to this electric field, there will be an electric force in the upward direction. Is it clear? Right? If we have magnetic field into the plane, let us say, sorry, not into the plane. If we have electric field in this direction, then the magnetic force will be in the downward direction, right? Is it clear? Right? Particle is moving. If this direction is X, this direction is Y, and this direction is Z, particle is moving in the Y direction. Magnetic field is in the X direction. So V cross B is in the downward direction, that is minus K cap. Electric force is in the positive K cap. So we can say electric field is balancing the magnetic field. Is it clear? Got it? So option D is also possible. So answer will be A, B, D, right? Okay.
Yes.
So this arrangement is known as a velocity selector. Velocity selector. Because here QE will be equals to QVB and V will be E by B, right? If a charged particle is having this velocity, it will pass undeflected by that cross field. Next, the acceleration due to gravity on the surface of Earth is g if the diameter of the Earth reduces to half of its original value and the mass remains constant. Then the acceleration due to gravity on the surface of the Earth would be. So what is happening here? So we are reducing the diameter of the Earth by half. And we know that g is capital G m by r square, right? So here we are reducing diameter to half its value, keeping mass constant. So r will become r by 2, right? So new acceleration due to gravity will become gm divided by r by 2 square. So which it will become 4 times gm by r square, which is 4 times g. Got it? Clear? So it becomes 4 times. Because we are keeping mass same, so we are not changing the mass, we are only changing the radius. Clear now? Next. A train is moving with a speed 12 meters per second on rails, which is 1.5 meter apart. The to negotiate a curve radius of 400
ये
meter.
कौन सा shift का है?
This is 27th Feb shift 1.
Oh,
The height by which the outer rail should be raised with respect to the inner rail. Okay, right. So what we have given. So let us say this is the inner rail, this is the outer rail, and there is a train. Which is moving on this rail, right? Clear? So I'm showing the cross-sectional view. And we have given rails which are 1.5 meters apart. So let us take this distance as 1.5 meter apart and the speed as 12 meters per second. And the radius is 400 meter. So what are all forces acting on the train? So there will be a normal reaction N. There will be a gravitational force mg, right? Okay. So Now what we can do, so we can resolve normal reaction in horizontal and vertical direction. So let us take this angle as theta. So this angle will be theta. So there will be two components. This will be mg cos theta, and sorry, not, I'm not resolving gravitational force. I will resolve normal reaction. So this angle is theta. So this angle will be theta. So it will be having two components. So this component will be n sine theta, and the vertical component will be n cos theta. Now the n cos theta component will balance the weight, and n sine theta component will provide centripetal acceleration. So we can say n sine theta will be m v square by r, and n cos theta will be equals to mg. So from here I can say tan theta will be equals to v square by rg. Got it? So here tan theta will be what? So this is 1.5, and what we have given, speed is given, and radius is also given. And we have to find the height by which the outer rail should be raised, and we have to find this distance, right? H. So tan theta will be h divided by 1.5, and this will be v is 12. So 12 square divided by r is 400, and g we can take it as 10. So h will be 12 times 1.5 divided by 4 into 10 raised to power 3. So this will be 3. So 4.5. So 12 into 4.5 into 10 raised to power minus 3, right? So this is in meters. So if I multiply this with 100, so 1.5, so I can write this as 3 by 2. So this will be 6. So we are getting around, how much we are getting? 18, I'm getting 18, 1.8. Why I'm getting 1.8? 4,144 into 1.5. 1.5. Let me check. Okay, right. There is 3 also, right? Into 3, right? So it comes out to be 5.4 centimeter. Clear? Right? So option 2 is the right answer. Next, which of the following circuits is reverse biased? So in case of a PN junction diode, this side is P side, this is N side. For reverse biased mode, P side should be at the low potential and N side should be at high potential, right? Let us see. So here, P side is 2 volts and N side is 0 volts. So this is forward biased. So 1 is not correct. Into P side is at 0 volt and N side is at -5. It is forward biased, right? Here, P side is at 2 volts and N side is at -10. So this is again forward biased. So here P side is 2 volts, N side is 4 volts. So the voltage at the N side is greater than the voltage at the P side. So this is reverse biased. So option 4 is the answer, right? Now let us see the next question. Identify the physical quantity that can't be measured using spherometer. Right. So what is a spherometer? So it is a device which is being used to find the radius of curvature of a surface. For example, I have a, say, a lens which is like this, right? And we want to find the radius of curvature of this lens. Let us say this lens is placed on a table. So there is a device which has 3 legs. So I'm showing only 2 legs, right? So it has 2 legs. And there is a screw. So there is a screw like this, right? So we can measure the displacement of the screw. So by measuring the displacement of the screw, we can find the radius of curvature, right? Is it clear?
Yes.
So it is used to measure radius of curvature of concave surface, and it is used to measure the thickness of the plate, radius of curvature of a convex surface, specific rotation of the liquids. Specific rotation of the liquid is a microscopic phenomena, and it is a very big object, right? So it is not used to measure the specific rotation of the liquid. So option 2 is the answer of this question, right? Which is not possible. Option 2, right? Okay, next.
Yes.
Two bodies of mass 4 grams and 25 grams are moving with equal kinetic energy. So they have same equal kinetic energy, the ratio of the magnitude of their linear momentum. So what is the relation between kinetic energy and linear momentum? It is p square by 2m is equals to kinetic energy, right? So we can say p1 square by 2m1 is equals to p2 square by 2m2 because their kinetic energies are same. So p, we have to find the ratio of momentum. So it will be p1 by p2 square is equals to 2m1 by 2m2. So 2 will get eliminated. So p1 by p2 will be square root of m1 by m2. Now what is m1? m1 is 4. What is m2? 25. So this will be 2 by 5. So 2 ratio 5, right? That is the answer. Next, 0.08 kilograms of air is heated at constant volume through 5 degree. So we have given mass that is 0.08 kilogram and at constant volume. So it's a constant volume process. So in constant volume process, work done is always 0, right? The specific heat of the air is, at constant volume is 0.17 kilocalorie per kilogram per degree Celsius. So S is given, that is 0.17 kilocalorie per kilogram per degree Celsius. And we have also given mechanical equivalent of heat. So 1 calorie is equivalent to 4.18 joules. The change in its internal energy. So we know that delta Q is equals to delta U plus delta W. Since it is a constant volume process, delta W is 0. And we have to find the change in internal energy. So it is nothing but delta Q. And what is delta Q? It is ms delta T, right? What is M? 0.17. What is specific heat capacity? So it will be 0.17 kilocalorie. So kilo is 10 raised to power 3. 1 calorie is equivalent to 4.18 joules. So this is in SI units multiplied with the increase in temperature. So 5. Got it? Right? So when we simplify this, we will get 284 joules. Is it clear? Again, it is a straightforward question. Next, the radius of third stationary orbit of electron.
Previous question.
Yeah. So what we have done here, delta W is 0 and delta Q is ms delta T. So first we have to convert specific heat capacity in SI units. So I have converted calorie into joules.
Yes.
Okay. Right. So next, the radius of the third stationary orbit of electron for Bohr's atom is R. So we have given R3 is equals to capital R. The radius of fourth stationary orbit. So if you remember, in atoms we have studied Rn is directly proportional to n square by z, right? Right. So if we apply this, so we have to find for fourth. So R4 by R3 will be 4 square upon 3 square, right? Is it clear? And this can be written as R4 will be R3 times 16 by 9 and R3 is nothing but capital R. So 16 by 9 R. So option 2 is the right answer. Next, a rectangular loop of length 2.5 meter and width 2 meter is placed at 60 degree to the magnetic field. So we have given a rectangular loop and its length is given as 2.5 meter and the width is given as 2 meter. And let us say this is the area vector. And it makes an angle of 60 degree. So magnetic field, which is 4 Tesla, this angle is given as 60 degree. The loop is removed from the field in 10 seconds. The average EMF induced in the loop during this time. So we know that EMF induced, average EMF induced will be what? It is minus d phi by dt, right? So here we can say EMF induced will be negative of delta phi by delta t. Okay.
Yes.
So what is the initial flux? So initial flux will be BA cos theta. So B is 4, area is 2.5 into 2, cos 60 is 1 by 2. So this comes out to be 10. Okay, 10 Weber is the flux. So what is the final flux? We have removed this loop from the field. So final flux is 0. And what is the time? Time is 10 seconds. So this will become minus of final minus initial divided by the duration. So final is 0, initial is 10, and the time is 10 seconds. So this will be 1 volt plus. Got it? So option 3 is the right answer. An electric charge 10 raised to power minus 6 microcoulomb is placed at the origin of XY coordinate system. 2 points P and Q are situated at root 3 comma root 3 and root 6 comma 0. The potential difference between the point P and Q. So we have given a point charge 10 raised to power minus 6 microcoulomb at the origin 0 comma 0. This is y and this is x-axis. And there is a point P which is, sorry, so this is point Q, right? Root 6 comma 0. And there is a point root 3 comma root 3. Now we have to find the potential difference between P and Q. So what is the formula of potential by a point charge? So potential is given by K Q by R, right? So if this is point charge, so we can say it will be, so we can write this as so what is this distance? So this is point P, right? And this is O. So OP will be, what is OP? OP will be square root of root 3 square plus root 3 square. So it comes out to be root 6. And what is OQ? That will be root of root 6 square plus 0 square. And this is again, you can say root 6. So OP and OQ are same. So potential at P will be KQ by root 6 and potential at Q is KQ by root 6. Since the potential at P and Q is same, so we can say the potential difference will be 0. So option 3 is the right answer. Next, a body of mass 1000 kilogram is moving horizontally with a velocity 6 meters per second. If 200 kilogram extra mass is added, the final velocity. So we have given 1000 kilogram of body which is moving with a velocity of 6 meter per second. Now what we have done, we have added 200 kilogram mass on this body. So now what we have done, so now we have added 200 kilogram more on 1000 kilogram. So earlier the mass of the system was 1000 kilogram. Now the mass has become 1200 kilogram. So if we apply momentum conservation, so conservation of linear momentum, so we can say 1000 times 6 should be equals to 1200 times V. So V is the velocity when we have added more mass on the 1000 kg mass. So this 2 zeros will get cancelled out. So this will be 2. So V comes out to be 10 by 2. That is 5 meters per second. So option 4 is the right answer. Now the next question, a plane electromagnetic wave propagating in X direction is described by this equation. EY is 200 sine 1.5 into 10 raised to power 70 minus 0.05x. The intensity of the wave is. So to solve this question, you should know what is the formula of intensity. So intensity will be given as half epsilon naught E naught square C. So that is the intensity of electromagnetic radiation. Now here we have given epsilon naught. We have given magnitude of the electric field and speed of light is 3 into 10 raised to power 8. So this will be half 8.85 into 10 raised to power minus 12 and E naught is 200 square of that and speed. So it is in vacuum. Okay, right. Let us find the speed. So this is omega and this is k. So speed is omega by k. So omega is 1.5 into 10 raised per 7 divided by 0.05. So this will become what? So this will become 30. So 3 into 10 raised per 8 meter per second. So into 3 into 10 raised per 8 meter per second, right? So if we simplify this, we will get 53.1 as the answer, right? Next question. Given below are two statements. Statement 1, Planck's constant and the angular momentum have same dimension. Let us see. So Planck constant, we know the formula E is equals to h nu. So h can be we can get h by E by nu. Now the dimension of E is m raised to power 1, L raised to power 2, T raised to power minus 2, and the dimension of frequency is T raised to power minus 1. So this will become m raised to power 1, L raised to power 2, T raised to power minus 1. Now let us find the dimension of angular momentum. So angular momentum is mvr. So its dimension will be m raised to power 1, L raised to power 1, T raised to power minus 1 times L raised to power 1, which is m raised to power 1, L raised to power 2, T raised to power minus 1. So can you see they have the same dimension? So it means statement 1 is correct. Statement 2, linear momentum and the moment of force have same dimension. So linear momentum is m times v. So its dimension will be m raised to power 1, L raised to power 1, T raised to power minus 1. And moment of a force is torque. So which is R cross F. So it is L raised to power 1, m raised to power 1, L raised to power 1, T raised to power minus 2. So it is m raised to power 1, L raised to power 2, T raised to power minus 2. So statement 2 is incorrect because the dimension of linear momentum and torque is not same. So statement 2 is incorrect. So statement 1 is true and statement 2 is incorrect, right? So this is the answer of this question. Next, a wire of length 10 centimeter and radius root 7 into 10 raised to power minus 4 meter connected across the right gap of a meter bridge. Okay, so we have given a meter bridge. And here we have, let us say, a wire, meter long wire, a wire of length 10 centimeter and radius. So here we have attached a wire of radius root 7 into 10 raised to power minus 4 meter. And the length of this wire is 10 centimeter. Connected across the right gap of the meter bridge when a resistance of 4.5 ohms is connected on the left gap. So if we connect a resistance of 4.5 ohms on the left gap by using a resistance box, the balance length is found to be 60 centimeter from the left end. So if there is a galvanometer, so balance length is somewhere here, and this distance is 60 centimeter. If this is 60, this will be 40. If the resistivity of the wire is R into 10 raised to power minus 7 ohms meter, then the value of R. So in balanced Wheatstone bridge, I can say 4.5 by 60 should be equals to, let us say it has a resistance R prime divided by 40. So resistance of the wire will be 4.5 by 60 times 40. So this will be 2, this will be 3, so it will be 1.5. So it will be having 3 ohms resistance. Now this wire has 3 ohms resistance. So we know that resistance is rho L by A. And here resistivity of the wire is given as R times 10 raised to power minus 7. So R times 10 raised to power minus 7 times length is 0.1 meter. Area will be pi R square. So that will be 7 into 10 raised to power minus 8. And R prime is 3. So from here R value, so I can write pi as 22 by 7. So this 7 will get eliminated. So R comes out to be, so this will give you 10 and this 10 will cancel out this. So R comes out to be 66. So R will be 66. So option 3 is the right answer. Now let us see the next question. A wire of resistance R and length L is cut into 5 equal parts. So now there is a wire of length L, and we have cut this wire into 5 equal parts. So this wire initially it has a resistance R, and we know that in case of a uniform wire, the resistance is directly proportional to the length. So for this part, the resistance will be R by 5, and for this it will be R by 5, right? So each small part will be having resistance R by 5. If these parts are joined parallelly, so now we have joined these 5 identical wires in parallel. Each will be having resistance R by 5. So their R equivalent will be R by 5 divided by 5. So that will be R by 25. So option 1 is the right answer. Again, very basic question. Next, the average kinetic energy of a monoatomic molecule is 0.414 electron volt at temperature. So what is the formula of average kinetic energy of monoatomic gas? It is 3 by 2 kBT. So 3 by 2 K is given as 1.38 into 10 raised per minus 23. And temperature we have to calculate. And the average kinetic energy is given as 0.414 electron volt. So 0.414 electron volt can be written as 0.414 into 1.6 into 10 raised per minus 19 in joules, right? So 0.414 times 1.6 into 10 raised per minus 19. So if we simplify this, again, a very basic calculation, if you simplify this, the answer comes out to be 3200 Kelvin, right? So option 2 will be the answer of this question. Now let us see the section B questions. So in section B, first question, a particle starts from origin at t equals to 0 with a velocity 5 I cap. So there is a particle which is starting from the origin with an initial velocity of 5 I cap meter per second at t equals to 0 and moves in the xy plane under the action of a force which produces a constant acceleration of 3 I cap plus 2 j cap. So acceleration is given as 3 I cap plus 2 j cap. If the x coordinate of the particle at that instant is 84, so if the x coordinate of the particle at that instant, so what is okay, right? Then the speed of the particle at this time is root alpha. Let us say after some time t, the particle x coordinate is 84, right? So what we have given? So we have given initial velocity in the x direction as 5 meter per second, acceleration in the x direction as 3 meter per second square, and the displacement x in time t as 84 meter. So if I want to find what is the time, so we can apply x equals to ut plus half at square. So x is 84, initial velocity is 5 times t plus half, a is 3 times t square. Now we have a quadratic, so let us simplify this. So 3t square plus 10t minus 168 equals to 0. Now we have a quadratic. Now let us simplify this. So t will be minus 10 plus minus root b square plus 4 into 3 into 168 divided by 2 into 3. Right, so 10 plus minus 46 divided by 6. So we will ignore the negative value. So this will become 46 minus 10 divided by 6. So it will be 56, 46 minus 10. So sorry, 36 divided by 6. So it will be 6 seconds. So the speed of the particle at that instant. So we can apply v equals to u plus at. So u is 5, a is 3, and time is 6. So it will be 5 plus 18. So it comes out to be 23. So and it is given as root of alpha. Now what is the square of I'm getting 23. 6. The speed, okay, right. So this is the x coordinate, right? So Vx will be this, right? Root 23. Now, what is the y coordinate at that time? So Vy will be 0 plus a acceleration in the y direction is 2 times t. T is 6. So 12. So we know what is what is Vx component, what is Vy component, right? So the speed will be root of Vx square plus Vy square. And this comes out to be 23 square plus 12 square, right? So this is the only question which has some calculation in it. And let us simplify this. So 23 square. So it will be root of 529 plus 144. 144. So it comes out to be root of 673. So which is alpha, root of alpha. So alpha will be 673. Right? I hope this question is clear to you. Next, a thin metallic wire having cross-sectional area 10 raised to power minus 4 is used to make a ring of radius 30 centimeter. So there is a ring. And we have formed a ring by using this uniform wire. And the cross-sectional area. So area is 10 raised to power minus 4 square meter and the radius is 30 centimeter. A positive charge of 2 pi coulomb is uniformly distributed over the ring. So we have distributed charge 2 pi coulomb. So let us say Q is 2 pi coulomb is uniformly distributed while another positive charge of 3 picocoulomb is kept at the center. And there is a charge of 3 picocoulomb at the center. The tension in the ring is, we have to find the tension in the ring provided that the ring does not get deformed. Okay, so whenever we have such kind of a question, we'll take a small element. So whenever we have to find the tension, we'll take a small element of the ring. Now let us say this is the small element. So I have magnified the view of the small element. And let us say this small element subtends an angle 2 theta at the center. Right? So this angle will be theta and this will be theta. And there is a charge of 30 picocoulomb at the center. And on this element, we have a positive charge. Now, what is the charge on the element? So we can say it will be dq. That will be q divided by 2 pi r times the length of the element. And the length of the element will be r d theta. So here the theta will be 2 theta, right? So this 2 will get cancelled, r will get cancelled. So it will be q upon pi times theta. So that is the charge. So due to the like nature, so we have a positive charge and the charge on the ring is also positive. So there will be a Coulomb repulsion. So there is a Coulomb
ये
repulsion.
इलेक्ट्रोस्टैटिक्स का है ना?
Yeah. So there will be a Coulomb repulsion and this Coulomb repulsion, let us say it is F. So this F will be K 30 pico Coulomb times dq, which is capital Q upon pi theta divided by the distance between them, that is nothing but the r square. And there will be a tension force. So there is tension T here, there is tension T. And let us take this. So this angle will be theta, this is theta, this is theta. For the equilibrium of this element, if you look at the component of tension, so there are horizontal components will get cancelled out. So T cos theta will get cancelled out with T cos theta and T sin theta will add up. Now this T sin theta will balance the Coulomb repulsion. So we will say this will be equals to 2T sin theta. Since theta is very small, sin theta can be written as theta. So this will be 9 into 10 raised to power 9 into 30 into 10 raised to power minus 12. Q is given as 2 pi theta upon pi and R is given as 30 centimeters, so 0.3 square and 2t times theta. So theta will get eliminated, so pi will get eliminated. So this will give us 100 and this 2 will get cancelled out. So we'll be having 3 into 10 raised per 11 plus 1 minus 12 T. So this is nothing but 3 Newton. So the tension in the ring will be 3 Newton. Got it? So this is the procedure how to tackle such questions. Next, two coils having mutual inductance 0.002 Henry and the charge current changes in the first coil according to the relation I equals to I naught sine omega t, where I naught is 5, omega is 50 pi radian per second. The maximum value of the EMF in the second coil is pi by alpha, the value of alpha. So EMF induced will be, so here it will be m times di by dt, right? So that is the EMF
Yes.
induced. And m is given as 2 into 10 raised per minus 3. And the rate of change of current. So we can differentiate this. So di
Yes.
by dt
I
will
naught
be
omega
I naught
cos
omega
wt.
cos omega t, right? So I naught omega cos omega t. And we have to find the maximum value. So the maximum value for maximum value cos omega t has to be 1. So E max will be 2 times 10 raised per minus 3. I naught is 5, omega is 50 pi. So this comes out to be 10. So this becomes 0.5 pi. So we can say it will be pi by 2. So 2 is the answer, right? Right. Next. Two immiscible liquids of refractive indices 8 by 5 and 3 by 2 respectively are put in a beaker as shown in the figure. The height of each column is 6 centimeter. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coin is alpha by 4. The value of alpha is, it is a standard problem. If you are looking at this coin from the top, the apparent depth will be given by 6 by mu1 plus 6 by mu2. 6 is this, right? So this is, if this is h1 and this is h2, the formula will be h1 by mu1 plus h2 by mu2. So it will be 6 divided by mu1 is 8 by 5 plus 6 by mu2, that is 3 by 2. So this will be 30 by 8 plus 12 by 3. So we can simplify this and it is in terms of alpha by 4. So this can be written as 90 plus 8, 96 divided by 24. And this will be 186 and this will be 8, 6 into 4. And this will be 31. So 31 by 4, which is alpha by 4. So alpha will be 31. Got it? Next. In a nuclear fission process, a high mass nuclide of mass number 236 with a binding energy 7.6 mega electron volt per nucleon dissociates into middle mass nuclides of mass number 118. So there is a heavy nucleus of mass number 236. It splits up into two lighter nuclei of having mass number 118 and 118. Having binding energy of 8.6 mega electron volt per nucleon. So can you see the binding energy has increased? The energy released in the process will be, so it will be binding energy of product minus binding energy of reactant. So that will be the energy released. So what is the binding energy of the product? So it will be 118 plus 118. So that is the total mass number multiplied with binding energy per nucleon minus 236 times 7.6. So from here, we can say 236 will be common. So 8.6 minus 7.6. So this comes out to be 1. So 236 mega electron volt is the answer. Got it? Next. Four particles each of mass 1 kilogram are placed at four corners of a square of side 2 meter. Moment of inertia of the system about an axis perpendicular to its plane and passing through one of its vertex is, so we have 4 point masses 1 kilogram each, and we have to find the moment of inertia about this axis. So the contribution towards moment of inertia for this particular mass will be 0 because it lies on the axis. Now we need to find the perpendicular distance of all the masses from the axis. So this is 2 meter. This distance is 2 root 2 meter. This is 2 meter. So moment of inertia will be 1 into 2 square plus 1 into 2 square plus 1 into 2 root 2 square. So 4 plus 4 plus 4 to the 8. So that will be 16. So 16 is the answer, right? Next, a particle executes simple harmonic motion with an amplitude of 4 centimeter. So amplitude is 4 centimeter. At the mean position, velocity of the particle is 10 meters per second, 10 centimeters per second. So at the mean position, velocity is maximum, which is a omega, right? And it is given as 10 centimeters per second. And a is 4. So from here, we can find omega. Now the distance of the particle from the mean position when its speed becomes 5. So we know that the relation between the position and the speed is v is equals to omega root a square minus x square in a simple harmonic motion. And v is given as 5 and omega is 10 by 4 from this equation. Amplitude is 4. So from here we can find x. So this will be 2, this will give 2. So 2 square is 4 square minus x square. So x square will be 16 minus 4. That is 12. So x comes out to be. So x, and we have given the x is nothing but root of alpha. So root of alpha square is 12. So alpha will be 12. So 12 is the answer of this question. Now next question. So two long straight wires carrying equal currents in opposite direction as shown in the figure. The separation between the wire is 5 centimeter. The magnitude of the magnetic field at the point P midway between the wire. Okay, right. So due to this wire, the field will be into the plane. And due to this wire, the field is again into the plane. So actually the field is adding up. So we'll find the magnetic field by one wire and we'll double that. So magnetic field is given by an infinite current carrying wire is mu naught I upon 2 pi r, where r is the distance of that point from the wire. So it can be, so if I multiply and divide by 2, so this will be 2 into 10 raised to power minus 7 multiplied with the current divided by r. R is 5 by 2, right? So 2.5 into 10 raised to power minus 2. Now we have to multiply this with 2 to get the answer because we have two wires. So this will be 5 by 2. So we have 8 by 5 into 10 raised to power minus 4. So this will be 1.6 into 10 raised to power minus 4. And we have to find answer in micro Tesla. So it will be 160 into 10 raised to power minus 6 Tesla. So it will be
Yes.
160 is the answer. The charge accumulated on the capacitor connected in the following circuit. So there is a capacitor and there are 4 resistors. In steady state, there is no current in the capacitor branch. So if there is no current, our equivalent circuit will look like this. So we can remove the capacitor. So this is 6, this is 1, this is 2, and this is 4. So 6 and 4 are in series, 1 and 2 are in series. So 6, so this will become so this is 10 and this is 3. Now 10 and 3 are in parallel. So 10 times 3 upon 10 plus 3. So 30 by 13. So 30 by 30 is R equivalent. So the current will be 10 divided by 30 by 13. Is it clear? So 13 by 3 is the current. So this is 13 by 3. So here we have 13 by 3. So in this branch, the current is I1. In this branch, the current is I2. So I1 will be 3 by 13 times 13 by 3, which is 1 ampere. And current in the second branch will be 10 by 13 times 13 by 3, which is 10 by 3. Clear? So if I move from A to B, so VA plus, so we are going from against the direction of the current. So there will be an increase in potential. So 1 times the current, that is I2. I2 is 10 by 3. and then we are going in the direction of the current, so minus 6 into 1, and we'll reach at B. So VA minus VB will be 6 minus 10 by 3, which is 18 minus 10 by 3, 8 by 3. Now that is the potential difference across the capacitor. So what is the charge? So charge will be CV. C is 150 microfarad and V is 8 by 3. So this will be 50. So this comes out to be 400 microcoulomb. Got it? Right. The last question. If average depth of the ocean is 4,000 meter and the bulk modulus of water is 2 into 10 raised per 9 Newton per meter square, then the fractional compression of water at the bottom of the ocean is this. What is the value of alpha? Okay, so we have given depth. So and we know that compression we have to calculate. And bulk modulus is given. So bulk modulus is 2 into 10 raised per 9 Newton per meter square. And H is given as 4,000 meter. And we know that bulk modulus is excess pressure divided by fractional change in the volume. So delta V by V will be delta P by B. And what is delta P? It will be rho GH, and B we have given. Rho is 10 raised per 3, G is 10, H is 4 into 10 raised per 3, bulk modulus is 2 into 10 raised per 9. So if I eliminate this, it will become 10 raised per minus 2. This will become 2. So 2 into 10 raised per minus 2. So alpha will be 2. Is it clear?
Yes.
That is the last question. So have you seen most of the question I was able to solve under, say, 1 minute, right? Right, Vedant?
Yes.
And some of the questions of section B were lengthy. Most of the question of section A were like short. Can
Yes.
be done within 1 minute. So if you so what you have to do, go through all papers of shift 1, right? Session 1, session 1. So go through that, what from which area the questions are coming, and practice those areas. If you do that, you will definitely increase your score by 40 to 50 marks.